Hello. So this video is going to focus on RP1, specifically the first part of that, which is preparing a standard solution. We're going to go through the method, and then we're going to look at how you might draw a results table and how you might use the data from that results table. We're going to look at ensuring accuracy, and finally we're going to do an exam question. So before we start, just so you're aware, I'm not actually a chemistry teacher, I'm actually a chemistry student. I just finished my A-levels and I got an A-star in chemistry. I'm going to go on to do a chemistry degree next year. So this is just my advice, I'm not a chemistry teacher. Also, because I study AQA, this is going to focus on the AQA specification. I'm sure there's some overlap with other boards, but we're focusing on AQA today. So, first thing I'd always do is go to the AQA practical handbook. There you'll find a method for every single required practical. You might also find some sample results and general notes and advice about the practical. I find this very useful because it gives me the complete method. However, this is a very long method, so what I used to do is I would copy and paste that into a Word document and cut out all the bits that aren't as important. That way I can just have the important steps and it's easier for me to memorize this for an exam. So as you can see here, I've taken that massive long method and I've narrowed it down to 7 steps, which is really helpful again for memorizing it, but also just for getting a better understanding. I'm not going to read it out because you have it written here, but pause the video if you like to read this method. And then also what I found helpful was actually drawing out the method. This is no amazing drawing, however it did the job because it helped me to connect the written method to what I'd actually do in a lab. I think it's especially helpful in an exam if you might forget what the practical is or which one they're referring to. You can kind of think about all the different ones you've done and how you'd actually do it in a lab. So I'd recommend this. No need for all the writing, pictures are fine, whatever form works best for you. So now, I thought it would be nice to look at all the important steps and basically why we do them and how they help us to ensure that our final results will be accurate. So, the first thing is weighing by difference. We must weigh by difference to calculate the exact mass of solid transferred. So this is one of the first steps you would do. You'd weigh your weighing boat and the solid that you're going to use for the experiment. You'd tip that out into your beaker and then you'd actually re-weigh that now empty weighing boat, because we want to make sure that we know exactly how much of that solid is transferred so that we know what mass to use for our final calculations. If some of that solid is left behind and we do not account for it, then it will affect our final concentration. So we really want to avoid this. The two ways of avoiding this are either weighing by difference, as I've described now. You can also see that kind of process on the top right and how we'd calculate the mass of solid transferred. Or alternatively, we could rinse the weighing boat. This actually ensures that all of the solid that we've measured out gets transferred into a beaker. This is also effective, but either way I think would be fine to write about in an exam. Next, following on from this, we're going to need a results table because we're doing a practical. You get marked on this as well. So, key things for our results table to note is that we have the units written once for each row. So in the brackets you have grams. There's no need to repeat that when you actually write the masses that you get. We only write it once. And you can see that for most balances, the precision will be 2 decimal points. So make sure that our masses recorded in the table are all to 2 decimal places. No more, no less. The data recorded in the table will be used to calculate the concentration of the standard solution produced. So anything that we write down here, we're going to need later for the actual analysis of the results. So, what do we want at the end of this? Well, we're making a standard solution, so we're going to need to know its concentration. So, to do that, we're going to have to recall the formula for concentration, which is moles over volume. Then I'd think, what part of that do I have? Well, I'm using a 250 centimeter cubed volumetric flask, so I know the volume, and I also know that I've added X amount of grams of our solid. So I have the volume, but I don't have the moles. So then I would think, okay, I have the mass though, so using the mass and RFM, I could calculate the moles. which is quite easy. You should know that formula. And then finally, note that usually the concentrations that we work in, the volume we want to use for it is going to be in decimeters cubed rather than centimeters cubed. So to calculate something in decimeters cubed, if we have it in centimeters cubed, we're going to want to divide by 1,000. Cool. So the next step, also to ensure accuracy, is rinsing the equipment. We're going to have to do this a lot in this practical, so it's important to know why and how we do it. So, similarly to why we weigh by difference, every time you transfer something from one beaker, let's say, to another, you're going to have some of that solution or solid or whatever left behind. And as you can imagine, as you go on and on in the practical, you'll be gradually losing more and more of what you're transferring. So we want to limit that as much as possible, especially in this because we need to know the actual full concentration of the standard solution. It's very important for the titration that follows this practical. So to limit this, we must rinse the beaker and the stirring rod to ensure that none of the solid is left on the equipment. If the solid is lost on the equipment, the moles and hence the final concentration will be affected. So when we rinse all of this equipment, we're going to pour that into the volumetric flask. What are we going to rinse? We're going to rinse the beaker, we're going to rinse the glass rod, and we're also probably going to have to rinse that funnel if we use one to transfer the solution from the beaker into the flask. And like I said, the washing should be poured into the volumetric flask. It's kind of a way of making sure that nothing is left behind and we don't lose any of that solid that we initially measured down. So, actually using the volumetric flask, this might be quite new because it's the first practical, the first one you're going to use a volumetric flask for. But like I said before, I think a volumetric flask has a graduation mark, right? It's this little mark about halfway through the long part of the flask, and that allows us to know that it's going to be exactly 250 centimeters cubed of solution in that flask. So when we're topping up our flask with the distilled water, we want to make sure that the meniscus sits exactly on that graduation mark. If we go over, we're going to have to start the whole thing again, so we don't want to do that. Also, when you're looking at the meniscus, you want to be exactly at eye level, like the diagram on the right shows. If you're not at eye level, it's going to be unclear, you can make mistakes. So, again, very, very important for standard solution in a volumetric flask, we need the meniscus to sit on top of that graduation mark. And as you're adding that distilled water, you're going to want to use a pipette towards the end so we don't go over. I think basically that's what I've just said. You can see the mark on the bottom left circle, that's our graduation mark. Pipette used to make sure we don't go over the meniscus, and then finally the meniscus shown there on the right. Cool. Kind of like the most important step, I think, is we want to make sure that our solution is homogeneous. What does that mean? It means that the concentration is the same throughout. I kind of like to think of it as, I liken it to putting dye in water, food coloring, something like that. So on the bottom right, you can see that image there. On the left, imagine if you just put food coloring in water and just left it, you didn't mix it. It wouldn't spread out as evenly, there would be gaps like you can see on there. However, if you mixed it, all of the water would go blue. So you can think of it in that way for concentration. We want the concentration to be the same throughout, we want to mix it up. How do we do that? Well, we have to stop at the volumetric flask, otherwise when you shake it, it's going to go everywhere. So we stop at that, and then I'm going to invert it, which means twist it up and down a couple of times, or multiple times, to ensure that it's homogeneous. Cool. We've reached the exam question now. I got this from Physics and Maths Tutor, the practical skills revision for AQA on their website. So also a great resource. They have the mark scheme on there as well. So if you have a quick read through of this question, you might want to pause the video and then I'll talk through it. So there are a few things in this question that give away that is going to relate to this practical. Firstly, the fact that we have a known mass of the solid in our solution, so we need to measure out accurately. Again, reminds me of the weighing by difference stuff, makes me think it might be this practical. Also the 250 centimeters cubed of the solution, that's an exact volume, makes me think of the 250 centimeter cubed volumetric flask. We have to describe the method, including the apparatus and practical details. So, 6-mark question, we're going to have to make quite a few points, but this is quite easy. It's basically the initial method that we had at the start. But again, if you want to do this now, pause the video. If not, I'll go on to the answer. So, again, basically the whole method, but simplified a little bit. So we're going to weigh out a known mass of the solid in the weighing boat and transfer this to our beaker. We're going to reweigh the weighing boat, aka weigh by difference. This is going to allow us to actually calculate the exact mass of the solid that is transferred. Next, we're going to dissolve the solid completely in distilled water. I'm going to stir this again with a stirring rod, might want to include that. Then we're going to transfer this solution to a 250 centimeter cubed volumetric flask using a funnel. Always helpful, you don't want to spill anything, you can put that in your risk assessment. Next, we're going to rinse everything that we've used. So rinse the beaker and the stirring rod, and again we're going to pour these washings into the flask. Finally, well not finally, but towards the end, we're going to top up with distilled water to the graduation mark using a pipette. Make sure we don't go over it, make sure we don't go under it, and the pipette prevents us from making any mistakes basically. Then I'm going to rinse the funnel because again some of the solid, it might have been left behind on the funnel too because it came into contact with the solution. And again we're going to pour these washings into the flask so that none of the solid is left behind. Finally, to create a homogeneous solution, we're going to stop at the flask so it doesn't spray everywhere. We're going to invert it to make sure it's mixed up and the concentration is the same throughout. This is the mark scheme. As for any 6 marker, it's going to be split into a few stages. Here we have 3 stages. We need to make sure that we fully, or as best we can, cover all the stages to get the full 6 marks. I would recommend looking at words that are underlined, so transfer to volumetric, flask, that's a key word, you need that. If you said flask, that's a bit vague, not sure about that. So yeah, always read through a mark scheme, self-assess your work. It will help you to be more confident in exams. So, just to recap, final slide, exam questions, they're rarely going to be like, write down the method for this, write down the method for that. They're more likely to say, what's the error in this method, or how could we make this method more accurate so we get better results? So this is what I would focus my practical revision on. So to ensure accuracy, what we've covered in this video was weighing by difference, to know how much solid we transferred, rinsing all the equipment so we don't lose any solid, reading the burette volumes, not the burette, basically making sure that the meniscus sits on top of the graduation mark. The burette is for the next part of this, which is the titration. And then finally, we're going to make sure that the solution is homogeneous, so we're going to invert the flask at the end. And that's basically it for this practical. I'd recommend doing some questions on this, but the question that I've given is basically the main one that they're going to ask you.